Good morning. Yesterday we looked at two-dimensional figures, and today we're looking at three-dimensional figures. So yeah, it'll be fun. This is, I think, what you guys expected of geometry. And we're going to go into the 3D figures even more, I think, the last quarter of this class. So this is just an introduction. So, of course, we have more vocab words. And the first word that we're looking at is surface. Okay, so that definition that's up there right now, a surface is a connected set of points in space having the thickness of a point, which is very similar to the definition for a plane. Okay, so surface can look like, making sure I'm going to draw this right, this or this. Okay, it is basically a 2D shape. That is your surface. It is the thickness of a point because there is no width to it. The next word that we're looking at is a sphere. So I think a lot of you guys already know what a sphere is, and we just have a few components of a sphere that we'll be looking at. So the sphere is the set of all points in space that are a given distance from a single point called the center. So much like a circle, except this is three-dimensional. And this segment that runs from the center to the outside point of the sphere is called the radius. So it's the same as the two-dimensional circle. A closed surface is a surface of finite size. So this means that it does not go on forever. It does have boundaries, and it divides space into an interior and an exterior. A solid is the union of that closed surface and its interior. Okay, so I'm going to use an example of a box, and you guys know how great I am at drawing on the computer. So bear with me. Okay, here is my box. If this were an empty box and it was completely hollow, it would be classified as a closed surface because the walls of the box are closed surfaces. There's an interior and an exterior. The solid would be like a block of cheese or like a toy block. Okay, it's solid. There's something inside of it. So that's why it says the union. Okay, that means the closed surface, the outside and the inside. So that would be completely filled in. The next word that we're looking at is a cone. I know a lot of you guys know this already. I'm sure you're imagining ice cream. We may have some ice cream later when we look at the 3D figures again as we're calculating volume and surface area. But today it's just the introduction. So a cone is the union of the region, of a region, and all segments that connect that boundary of the region with a specific non-coplanar point. Okay, so here's my region, my closed region. It's a circle. And then here's my non-coplanar point. So that point is called the vertex. And anytime I connect my region to that vertex, it makes a cone. The cone's base is the region in the plane. In this case, it is a closed curve-ish. I tried. The line segment that connects the point to the curve is called the lateral surface. And I'm gonna try to highlight this. So this right here is the lateral surface. Oh, and the circle part's the base. I guess I should have. Okay, base. Next word that we have is a cylinder. A cylinder is the union of two regions of the same size and shape in different parallel planes. Okay, so No, I'm going to go ahead and make the cylinder that you imagine. Okay, so those are my two regions of the same size and shape, and then the set of segments that connects the corresponding points. So ideally, I mean, with my picture, I only have the two segments, but in an actual three-dimensional object, there are several, right? It completely goes around. There's always a segment connecting the top to the bottom. So it's important to know that this counts as a cylinder, but if I had a circle top and a square bottom, this would not be a cylinder. Okay, they need to have the same, look at that, so ugly. It does not match up well at all. That would not count as a cylinder. Each of the two regions is called the base of the cylinder. So here are my bases. I'm going to try to draw that again. And the parallel segments that connects the two bases are called the lateral surface. So my lateral surface is basically the side. Ooh, that yellow's not going to show up very well. I apologize. Sorry. Circular. A cylinder or a cone is circular if the base is a circular region. Does this mean that there are cones or cylinders that do not have a circular base? Yes, actually, we're going to see them in just a minute. So I already drew my examples of that circular cone and the circular cylinder because that's how we see them in our heads, right? That's what we learned in elementary school and maybe even middle school. So the first cone that we're looking at is called a pyramid. Okay, this is technically a cone because its base is a region, and this is going to be a square-based pyramid. And here's my non-coplanar point, that is the vertex, and it connects to every point on the region base. So pyramid is a cone. It's important to know that. As in, it will probably be on a quiz or test or something. Now we're looking at a prism. A prism is technically a cylinder with a polygon as its base. So most of the times when we see prisms, you know, I wish I could just like copy and paste the shape that I already made so that way this was more exact. Oh well. That's a segment. It's supposed to be a segment. But this is a prism with the base of a square. So I'm going to highlight those bases so you know this is the base of my prism. And then this is a lateral side, lateral surface. And that would be all of these surfaces, by the way. Prisms and pyramids are further classified by their bases. So it's a circular cylinder or it's a rectangular prism. We're going to see that terminology very soon. If the segments forming the lateral surface of a prism or cylinder are perpendicular to the base, it is further classified as right. So we can see this right here, that it is not perpendicular. See that lateral side? It's not perpendicular. So that is not called a right cylinder. So I want you to keep this picture in mind because we're going to, you know, I'll just already tell you what it is. And then in the next slide, you'll see the vocab word. So this cylinder that is not right is called oblique. And here's the sentence for that on the PowerPoint. So cones and cylinders that are not right are called oblique. And yes, you can have oblique cones. It makes you sad because you probably can't have ice cream in it. A pyramid or a prism is regular. Okay, if you remember regular from yesterday, regular was when they have the same angles and the same side length. Okay, it is considered regular if it is right and its base is a regular polygon. So it needs those two things. It needs to be right, so perpendicular, and its base is a regular polygon. Okay, the lateral surface of a pyramid consists of triangular regions, each being a lateral face of the pyramid. So let's look at this vocab again. We have the base. Whoops, I meant to do the highlighter. JK. Okay. So we have the base over here, which is a square. And then the lateral face of this pyramid is a triangle. Do you see this triangle right here? Okay, bonus points. Who knows what to call that triangle that I just highlighted? Who remembers how to name it? I'm going to go ahead and make a triangle. It is called triangle. And I mean, there are different ways that you can call it, but I'm going to go ahead and say it's DON. Okay, I decided to start here and then name it clockwise. But just remember to include all of those vertices. The segment formed by the intersection of the two lateral faces is called the lateral edge. So I'm going to highlight that in blue. So here's the lateral edge, and here's the lateral edge. So we can see that the lateral edges are not planes, which means that we're going to name them differently. One of the lateral edges that we have is called DM. And it is a segment, so I'm going to put the segment on top. Okay, what's the name of another lateral edge? DN would be another one. I'm not going to write the last one, or I guess there are technically two more, but the last one that I've highlighted is DO, the segment DO, or OD. Okay, first example. We have a right square pyramid on the right over here, and we're just going to practice labeling it. What would we call the vertex? Remember that the vertex is a point, so we're just going to call it by its capital letter, D. Okay, how about the base? So its base is a square that was given. The base is a square. I'm going to go ahead and make a square. And remember that we have to call it by the vertices of the plane and in an order. Okay, whether you use clockwise or counterclockwise, either a way is fine. I'm going to try to do it in alphabetical order this time. So I'm going to start with L and then start naming them in that direction. That's L, M, N, O. Okay, and then a lateral face. So that lateral face is, I mean, there's several. Okay, I'm going to, let's do this one. So here's my lateral face. It's a triangle, triangular region. So I'm going to go ahead and make a triangle here. And then what are the vertices of that triangle? It doesn't matter which point you start at. I guess I could start at M and go this way. So that's M, N, D. So you could also call it triangle DNM or DMN, so long as you're doing it in an order. And then the lateral edge. So I'm going to highlight that in a different color. We have a couple, right? We have 4 lateral edges. Okay, well, we could just name one of them. Let's do DM. There we go. And don't forget that segment line on top, because that reminds us that it is a segment. It's a lateral edge. Alright, this is the fun bit. Let's look at different types of polyhedron. So polyhedron is a closed surface that is made up of polygonal, I feel like I'm saying that wrong, regions, okay? So the region forms the face of the polyhedron. I'm sure you guys already know some polyhedrons, and we're going to look at how we classify them in just a moment, okay? Okay. So the first one that we're looking at is called a tetrahedron, and I believe your book has pictures. I don't have the book in front of me, so I can't tell you on which page, but pretty sure there are pictures on there. So that's a tetrahedron that has 5 faces. A pentahedron. I'm sorry, tetrahedron has 4. I'm reading ahead. A penta has 5. Hexa, 6. Hepta, 7. Octa, 8. Okay, so these are prefixes that we've seen before. Okay, dodeca, there it is. And this is the new one. The icosahedron. Excuse me. Icosahedron. Okay, and that's 20 faces. That's a fun one. If you don't see it in your book already, wait till you see this guy. It's fun. Okay, so here we're just going to be classifying the polyhedron. That's all we're doing. Let's talk about it. Okay, this one is going to be the first one that we look at, A. Okay, how many faces does it have? I can see 1 right here, and 2. I see 3. A triangle in the back. I know this isn't pretty, sorry. And then 4. So what do you call a polyhedron that has 4 faces? Whoops, I thought that was the eraser. My bad. That is the tetrahedron. And then what are the shape of those faces? It's triangular. It's a triangular tetrahedron. Okay. Then we are looking at this guy right here. These are not labeled, so I'm going to go ahead and label them. They're labeled in your book, I think. Okay. So B, how many sides does it have? So it looks like a pyramid stacked on top of another pyramid. And if a pyramid has a square base, which is what it looks like right here. Okay, you guys need to have some imagination, I guess, to see all of these lines in your head. It's like 3D space. So that's a square base, which means I have 4 lateral surfaces, and they're all triangular on top and the bottom. 4 on top and 4 on the bottom. 4 triangle faces means that this is, 4 on top, 4 on the bottom makes 8. So 8 faces make an octahedron. Okay, C looks a little easier. Okay, all of the faces here are rectangles. So we have the 2 on the bottom, the 2 bases, 1, 2, and then we have 1, 2, 3, 4 faces. So that is 6. 6 would make it a hexahedron. And there's another name that we can call this too, right? I said that it had bases. It had bases, and then that makes it a prism. And since it is a prism and the base is a quadrilateral of some sort, we can call it a quadrilateral prism. So hexahedron and quadrilateral prism. Let's look at D over here. So this has a base of a pentagon, which means it has 5 triangular lateral surfaces. So how many total surfaces is that? 5 lateral and 1 base. That's 6 surfaces. So that's another hexahedron. But since it has a base and then it goes up to a vertex, this also makes it a type of cone, right? Or more specifically, a pyramid with the base of a pentagon. And the last one, E. This is the fun one. I mean, you can try counting up all these little triangles. There's a lot of them. So you can imagine that this is the icosahedron. Yep, that fun thing right there. Okay, so for polyhedron, the intersection of the adjacent, adjacent, remember, means next to, like our adjacent townhomes. Adjacent faces is an edge, and the endpoints of the edges are called vertices. I'm going to go ahead and try to draw this for you. Okay, so just a reminder, here's the edge. Whoops, that did not trace well. And then the vertices. I'm going to do that in blue. So this says 1, 2, 3, 4, and 5 vertices. A regular polyhedron is convex. Okay, that means the points are going out. It's a convex polyhedron whose faces are all identical. Regular polygon. And they have the same number of edges meeting at each vertex. So there are only 5 possible regular polyhedra. Just 5. So these are the 5 that we have. We have the regular tetrahedron, okay, with all of my equilateral triangles. We have the regular octahedron, which are also using that also uses the regular triangles. The dodecahedron, okay, what shape is this here that a dodecahedron uses? That is a regular pentagon. And the icosahedron uses the regular triangle again. Oh, and I almost forgot this guy. This is the one that we all know, right? Okay, that's our cube. That is also called the regular hexahedron because it has 6 sides. All right, so that's it. You guys have the rest of the time to do your classwork, so you don't have any homework today.